All right, now in this video, we're going to investigate why that's true. Why it's true that 5 choose 2 is equal to 5 choose 3. So here I have a table. You can think of this as, we will see that this is a function, right? We will see that this is in fact a function. Okay, so 2 element subsets of the set S. And so you can start to think, okay, so this is all 2 element subsets of the set S. This is all 3 element subsets of the set S. And you want to think about what is this mapping? What is this mapping from 2 element subsets to 3 element subsets of S? And this is our set S in this case. All right, so notice that 1, 2 is mapped over to 3, 4, 5, and then 1, 3 is mapped over to 2, 4, 5. And so you can, so notice that everything's getting mapped to its complement. Everything is getting mapped to the thing, to the complement in S. So remember that the complement of the set 1, 2, this is the set of all x in S such that x is let's say x is not in 1, 2. That's that set. Okay, so it's the set of all elements of S that aren't in that set, and that's exactly what that is, right? Or the set of all elements in S that aren't in the set containing 1, 3 is 2, 4, 5. All right, so we're mapping from 2 element subsets to 3 element subsets using the complement. And we've seen similar things to this in the functions worksheets. So let's see, 1, 4, that maps over to, let's see, 2, 3, 5. Let's see, 2, 3 goes over to 1, 2, 3, 4, 5. 2, 5 goes over to 1, 2, 3, 4, 5 there. 3, 5, let's see, what's not in 3, 5? That's in S. We've got 1, 2, and 4. 4, 5, what's in S that's not in 4, 5? 1, 2, 3. Okay, so what would go over to 1, 3, 5? You would have, let's see, you'd have a 2 and a 4. And what would go over to 2, 3, 4? 1 and a 5, right? 1 and a 5. Okay. So now remember that we can only, this is only a function if all of these are different, and all of those are different. You can check here. Let's just check real fast. Yeah, all those are different. Okay, is that all of the 2 element subsets? Let's see. 1, 2, 1, 3, 1, 4, 1, 5. Okay, now let's do the 2's. 2, 1, that's already taken up there. Remember, order doesn't matter. 2, 1, 2, 2, well, that would be a 1 element subset. 2, 3, 2, 4, 2, 5. Okay, we got those. Now 3, 3, 1, that's already taken up. 3, 2, that's already used. 3, 2, 3, 3, that would be 1 element. 3, 4, there it is. 3, 5, okay. And then 4, 4, 1, already taken up with 1, 4, 4, 1, yeah, and so on and so on and so on. Yes, these are all different. Okay, these are all different there. And these are all different, so it's 1 to 1. And there's no D in E's, so it's onto. So you can see that this function, and the function, if you want to have a rule for this function, the function is f of, let's say, xy gets sent to xy complement, where x and y are two different elements of S. Right, so you can see this function is one-to-one and onto, so there's a mapping, this function is a mapping. So there is a bijection from the two-element subsets of S to the three-element subsets of S. And so therefore, they have the same cardinality, right? Two sets have the same cardinality when there's a bijection between those sets. So here we have all of the two-element subsets of S and all of the three-element subsets of S, and there's a bijection between them, so there's got to be the same amount. Now, how many things are there over here? How many things are there over here? Well, this is all of the two-element subsets of a set with 5 elements. That's 5 choose 2. And how many things are over here? Well, this is all of the 3-element subsets of a set with 5 elements. So there's got to be 5 choose 3 here. So this is why 5 choose 2 is equal to 5 choose 3. 3 meaning 3, otherwise known as 5 minus 2. And if you do this same sort of mapping thing, in general, that's why n choose r is equal to n choose n minus r.